So, something that you probably know, hopefully, at this point, when you're talking about numbers, this number, let me make that a little bigger. This number right here is the same thing as this number right here. And just like that, this number right here is the same thing as this number right here. Okay, sorry, that's not a 6, that's a 0. Let's make it look like a 0. There we go. We'll just move on. So this is the same as that, that's the same as that. But when we are talking about, when you're doing science and you're writing numbers down, the way that you write the number, this versus this, is actually communicating information. It communicates the precision to which you are able to measure something. Okay? So when we look at, say, like the number 1.0 or 1.0000000, we're communicating something here about the precision of the tool we are using to measure with. So which one, option A or option B, was used to measure or was measured with a more precise tool, and why? Or how do you know that? Okay, so hopefully you chose B. And why could be because you can see they recorded to more place values, so they were able to get a smaller value or measure to a smaller place than they were here. Okay, and so for example, let's say you're using a meter stick and you're measuring something in meters. So we can measure to about, we can see millimeters on there, so maybe you can measure to like 1.23 centimeters, maybe 1.234, so including the millimeters. It would be difficult to guess between the millimeters. So this is really probably the best precision you could get with a meter stick. Some people would argue that maybe you could add another digit there at the end, but really this is probably the best that you could get with the meter stick, just because the way that you use a meter stick, you could probably have it shifted by a millimeter and not even realize it. Okay, so generally when you write a number, though, what you're indicating is that you're able to see, to clearly measure this place, this place, this place, and then this last place is an estimate. Okay, so let me go ahead and give you an example of this. Okay, so here we have an instance of something being measured in centimeters with this ruler right here, and the question I have for you is, if these three students each took a measurement here, which student is correct in the amount of precision they're using, and why? Hopefully you chose student 3, okay? Because what we're able to do here is we can measure, we can see the 11, we can count over 1, 2, 3, 4, 5, 6, and it's somewhere in between 6 and 7 right here, okay? And so we're going to estimate that it's about 3, okay? And remember, this number is an estimate, so if it was a 4, that'd be fine. If it was a 2, that'd be fine, okay? This student right here undersold their precision because clearly it's a little bit more than 11.6, and they can see that, and so they could probably say, they could probably make an estimate to where it is. And then this student right here is overselling their precision, because this means that there would be, for this 8 right here, that would mean that there were 10 lines right here in between that they could read and guess between. And then between those lines there's 10 more, and between those there's 10 more, and in between those there's 10 more, and between those there's 10 more. So 1, 2, 3, 4, 5. So basically they're indicating that between these two lines there are 5,000 other lines, and they're able to use those 5,000 lines, or sorry, what did I say, 5? That would be 1, 2, 3, 4, 5. So that'd be 100,000 other lines. They're saying there's 100,000 other lines that they could guess between, estimate between the last one to get that 6. And it's just, this is clearly an answer that's much more precise than what they were able to measure. And so it's important for you to understand that you're communicating something about the precision of your numbers when you write a number down after you take a measurement. And in this class, I'm not going to mark you down for incorrect significant figures, which is what these are called. And there's lots of rules that we could go into about how to do operations with things with different amounts of significant figures. So for example, you would say that this number has 4 significant figures. If you multiplied it by something with, say, 3, so 5.00, then there's a rule for how many significant figures your answer would have. Okay, we're not going to go into those rules, but if it's something you're interested in, you can. Okay, so I want you to be aware of this, because when you're writing an answer down, don't get carried away with all of these numbers. Okay, and like on that, say like if you take an AP test, when you're taking that test, don't write down all these numbers. It's okay if you don't have the exact right amount of sig figs, but you need to understand that sig figs do matter and not go way overboard like in this example right there. Okay.